when you differentiate with the chain rule, let's have a look at what happens. Suppose I differentiate this. Well, it's something to the power of 7. So I'm going to differentiate that to 7 times the something to the power of 6. And then I have to multiply by the derivative of the something, the derivative of the inside, which in this case, x squared, is 2x. Effectively what I've done is I've substituted another variable u for this thing that's inside the brackets. So I substitute, I do the differentiation with respect to the u, and then I expand it out again. Integrating by substitution is effectively using the chain rule backwards. Using the chain rule to make an appropriate substitution so that you can integrate something more complex. So let me show you. The substitution rule is written like this, right? The integral of some function of u times du dx with respect to x is just the integral of f of u with respect to u. You can, if you like, sort of think of this as du dx times dx. You can kind of think you're crossing out the dx. You're not really, but it helps you to figure out what you have to do. So let's do this, the example we just looked at, but working backwards. How do I integrate this complex expression? Well, it's something here to the power of 6 times this thing here looks like the derivative of the something in brackets. And that's what you're going to be looking for to make an appropriate substitution. So here you're going to say, I'm going to make u be this thing in brackets, x squared plus 3. Because then I can say I'm actually integrating 7u to the 6 multiplied by the derivative of u. So we write u being the bit inside the brackets, x squared plus 3, and therefore its derivative is 2x. And here's the kind of slightly hand-waving bit. Effectively we're saying from this that du is 2x dx. We've kind of cross-multiplied by dx. We haven't really done this because there's some tricky limits and things under the covers here. But you can sort of think of it this way. Because then we can write our original integral, this one, as the integral of 7u to the 6 du dx dx. And then we use integration by substitution, or the chain rule. This bit becomes just du. So then I'm integrating this with respect to u, which is u to the 7 plus a constant. Finally, I need to express my answer in terms of the original question, which was x. So replace u with x squared plus 3. Now, you may also hear integration by substitution being called change of variables. You should be able to understand why. We're turning an x into a u. The hardest bit is usually figuring out what you're going to use to substitute. You need to look for something that's in a complex function multiplied by its derivative, or at least something like its derivative. So here, for example, the bit under the brackets, x to the 5 plus 7, would be a good substitution. It isn't exactly the same as what's out here. X to the 5 plus 7, when you differentiate it, will turn into 5x to the 4th. Well, here I've got 3x to the 4th, which is pretty close. It differs only by a constant. That's good enough. Sometimes you'll have to try 3 or 4 things before you work out a substitution that's going to work well.